In this video, I'm going to show you how to break water. Take the molecules apart, capture the hydrogen and oxygen, and then put it back together again to make new water. This is something you can do at home. First, a mini demonstration. Water actually doesn't conduct electricity very well at all. In order to conduct electricity, you need to add some ions to help move the electrons along. Here I'm putting some baking soda in one of my cups and stirring it up, and then I'll put some salt in the cup on the left. The cup on the right will remain plain water. Let's see what difference that makes when I add a battery to each cup. Here you see in the first cup, not much is happening at the top of that battery, but in the baking soda cup, as soon as the battery goes in, we see lots of gas coming off of the two terminals. On the negative terminal on the right, you see hydrogen and oxygen coming off of the positive terminal, and the same with the saltwater battery. This means if we're going to use the electricity from a 9-volt battery to break the water molecules, we're going to have to add something to the water to help it along. Here I'm collecting my materials for this experiment. I have a beaker for my container. You could use any kind of a bowl or large container. I'm using a couple of test tubes. Here I have alligator clips, and I'm connecting a stick of graphite to each clip. You can use pencil lead for this. Just sharpen both ends of a pencil. That'll work fine. Those are called electrodes, and one goes in each test tube. But now I have to have everything filled with water. So I'm working in a bucket of water. Try to get everything put together so the test tubes are completely filled with water, even though they're upside down. And here you see it. Test tubes are full, standing up in the water, and the electrodes are inside the test tubes. Now we're ready to add some baking soda to the water. A couple of spoonfuls should do. Once I stir it up and dissolve the baking soda, the water will have lots of ions. Those are atoms that have a negative or positive charge. When electricity goes into the water, it will easily move through the water from one electrode to the other, and that will break the water molecules. Now we'll hook up the 9-volt battery. These alligator clips have a special piece to snap onto the 9-volt battery, but if you have just a pair of alligator clips that'll clip at both ends, you can easily hook it on just as well. These are not hard to find online. And you can see immediately that bubbles are rising in the tubes. And here's where it gets interesting. As we look closer, which tube is producing the most gas? And what gas would that be? Remember, water is H2O, 2 hydrogen atoms for every oxygen atom. Here it is 5 minutes later. Gas is flowing pretty well. And you've probably figured out the tube on the left is filling with hydrogen. If all goes well, it should fill up exactly twice as fast as the oxygen tube. And here it is the next morning. You can see the chemical changes in this jar have discolored the water quite a bit. That's the oxygen doing that. The tube on the left that's clear is hydrogen. And I set it up in another jar as well. That one also worked. Since that worked out so well, I decided to set up another example using 2 large graduated cylinders. I have them propped up so they can't lift up when they get filled with gas and fall over. Here you see the wires, and I have 2 large graphite sticks inside with alligator clips, all set up. This water also has dissolved baking soda in it. And this time I hooked it up to 5 9-volt batteries that are hooked together in series. And you can see the bubbles are starting to come up. Here it is a little while later. The oxygen tube again is becoming discolored. Definitely more hydrogen on the right. And here it is the next day. And it looks like my oxygen tube is failing to collect the oxygen. It must be leaking out, but that's okay. It's the hydrogen I want. And on the second day, I decided to up the batteries to 10 for one final push before I test out this hydrogen. See the gas rising there from the electrode. What I want to do is find out just how flammable is hydrogen. Hydrogen is highly flammable. When you light it on fire, it combines with oxygen to make new water. Let's try it with a couple of test tubes. Make some soap bubbles, and you see them burst into flames. And that's making new water. And here it is again with another test tube of hydrogen. with another test tube of hydrogen. But if we want a big bang, we're going to need a lot more hydrogen.